So hello everyone, this is the next video of my GFG POTD playlist, and the question is sum of job of all pairs. And so the difficulty level of question is medium. For the last 3 or 4 days, we are seeing that all questions are coming from the bit manipulation and sorting techniques. But this is a different questions. Although this is a bit manipulation techniques, but also this is a different kind of questions. So first we will saw the problem statement of the question. So let's focus on the how we approach the questions. So first we will form the problem statement of the question. Then at second we will solve it with brute force approach. Solve it with brute force approach, and then we'll analyze its time complexity. Then we will analyze its time complexity and space complexity. Then probably then most then probably we will code it. We will code it with brute force approach. With brute force approach, then it will throw TLE. It will throw TLE. Then we will move to optimize the solution. Move to optimize the solution. Optimize the solution. After that, optimizing the solution, I will like first tell the intuition behind that, behind the solution. Then I will code it. Then I will code. I will code that solution. This is the total workflow, or the you can say the total roadmap to solve the questions. Total approach to solve the questions. So, as I first discussed, let's discuss the problem statement of the questions. So, let's discuss the problem statement of the question in the next slide. Yeah. So, what are the problem statement states? So, first of all, I copy the questions from here to here. Yeah. So, it is copied now. So, actually, what the question says? Question says the given array of n size, and we have to make the bitwise XOR of distinct pair of elements, that is consider every pair of I and j, that is I less than j, and both I and j must be greater than equal to 0 or less than n, because this is in 0th bit indexing. So the array indexing is from 0 to n minus 1. So we have to perform the XOR operations between array of I and array of j, and each and every time the XOR result will be added, will be sum, and after that total sum will be returned as our answer. This is the questions. So let's first take our first question. First, what can we say? First test case. The first test case is like first. I will like to copy this. Yes, this is the first test case. So if you go through the like for 7, its binary representation is 1 1 1. Then, when 7 and 3 will be paired and XOR, 7 and 3 will be paired and XOR, it will be resultant as 3. So, how 3? So to know that, we have to first know that what is XOR operation. So, basically, XOR is a bitwise bit operation, bit manipulation operations, where 1 and 0. So, let me write the XOR rule. XOR rule 1 XOR 0 will produce 1, 0 XOR 1 will produce 1. And if any two bits are same, like 1 XOR 1 or equal 0, or 0 0 XOR 0 will produce 0. So this is the total XOR operation per bit. So to solve the questions, like if you careful observe that 1 1 1 and XOR 0 1 1. So as I have discussed the XOR rule, so the 0 bit would produce 0 because the all value is 0. Then 0 bit will produce 0. The first bit, like 1 and 1, will produce also 0. But the second bit produce 1. So what will be the answer? The resultant answer will be 4. This is the XOR operation. So if we take that pair 7 or 3, then for that XOR operation is 7 XOR 3, that is 4. Then if we take the 7 XOR 5 operation, 7 XOR 5, then it will produce what? It will produce 1 1 1 XOR 1 0 1. That is what? That is 2 0 1 0. Same logic applies here also. And when 3 XOR 5 will be applied, 3 XOR 5, with the same logic, we can say 0 1 1 1 XOR 1 0 1 will be resultant will be as like what will be result? You can easily say the result will be 1 1 0. That is 6. So total sum will be what? 6 plus 4 plus 2. That is 2. That is total sum. What will the total sum will be what? Total sum will be 6 plus 4 plus 2. That is 12. So our expected answer should be 12, and the output is also 12. So our intuition or our understanding behind the questions is perfectly correct. Then if we see that second test case also, the explanation is also given here. So uh, in the same way that XOR of every pair is calculated here, after that sum is calculated. So it is simply like 47. So if in the third test case, as there is only single element, so no such pair exists here. So the sum is 0 here. That is the question. So if we first see the questions, so what the first approach will be in our mind? The first approach will be in our mind, like we have to check every pair, and for every pair we have to calculate the XOR, and after that the XOR value will be added to an variable, that is sum variable, and at last we have to return that sum variable. So this is our answer. So like for that, if we want to make the pseudocode. So what will be the pseudocode? Like for I 0 to n 0 to n. So what is n here? The n is number of for 0 to n minus 1, because we are considering here the n zero based indexing. We are considering a zero based indexing, so that if the array size is n, so the last element index will be n minus 1. And there will be nested loop for j, that is I2 n minus 1. Sorry, that is I plus 1, because here is perfectly mentioned I should be strictly greater than j. J should be strictly greater than I. So I plus 2 to n minus 1. So each and every case we have to calculate a XOR operation. So the XOR equal to array of I XOR array of j. So we can easily calculate XOR operation in big of one time, big of in constant time also. So first step, we to sum that XOR, we have to take in some variable, that is sum equal to 0, will be initialized with 0. After that, each time is XOR is calculated, then we will be just sum plus XOR. It will be sum it with the calculated XOR here. That it will be capital XOR. So at last, this is our final answer, and at last we have to return the XOR operation, right? Return the sum operations. This is a like brute force approach. So let me first code it as I have said here. So first of all, I would like to like comment it out, because this is optimized solution. side comment turns out. Let's code it as brute force approach. Okay. So we have to take what is it? So we have to take any sum variable that as the return type is here given as long. So I am giving as sum as long. Okay. So after that, as I have said, for I equal to 0 to uh, area of length I plus plus for int j equal to I plus 1 j area of length j plus plus int XOR will be what will be int XOR? Int XOR will be area pi XOR area pi j. That is so. This is the so inform you this is the XOR operations. This is a XOR operation. Okay. After that, we'll just add it with the sum variable. At last, we have to return that sum variable. This is the brute force approach. So let me compile it. It's compiled successfully. Let me submit it. So as you see, this is time limit exceeded. TLE. So why it is giving TLE? So to understand that, we have to see our pseudocode and analyze the time complexity. So as the array size is n minus 1, the outer loop is 0 to n minus 1, and the inner loop is I plus 1 to n minus 1. So let me calculate the actual time complexity. Okay. So when I equal to 0, when I equal to 0, then from where to where j travels, then j travels from I plus 1, that is 1 to n minus 1. Okay. When I equal to 2, I equal to 1, sorry, j travels from where to where? J travels from 2 to n minus 1. So for first case, j travels how many elements? Like n minus 1, 1. So n minus 1 element, okay? And the second test case, j travels how many elements? J travels n minus 2 elements. And it will continues for I equal to like after till I equal to n. So it will continue to I equal to n minus 1. Okay. Then j travels from n minus 1 to n minus 1 itself. Okay. I equal to n minus 2. Sorry. N minus 1. That is how many elements? That is one element. So if we sum them up, okay, then if we sum them up, like how many times it like taking, let me sum it up. Let me take another slide here also. Okay. So it will be like n minus 1 plus n minus 2 plus n minus 3 and so on, like dot 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 plus 1. Okay. So if you carefully observe that how many times like it is if we make that n minus 2, n minus 3 and plus dot dot dot. Okay. Okay. I'm explaining in so detail because you can easily analyze the time complexity also. Okay. So that's why I am taking so much in detail here only. So if we carefully observe that the 1 to n minus 1, it means that this n is coming like n minus 1 times. 1, 2, 3, n minus 1 times. So n is coming how many times? N minus 1 times. N is coming n minus 1 times. Okay. And if you carefully see that it is or also 1 plus 2 plus 3 plus dot dot dot, that is n minus 1. Okay. So you can easily calculate the total time complexity. That is, this is the sum of n natural numbers. That is n minus 1 into n minus 1 plus 1, that is n by 2. Okay. So if you carefully observe that what is the time complexity. That time complexity is coming out n into n minus 1 by 2. Okay. So as we calculate our time complexity in terms of asymptotic notation, this comes out like big of n square. Big of n square. So that's why this is giving TLE, because here n is like giving 10 to the power 5. So we have to optimize that, because 10 to the power 5 means 10 to the power 12, 10. And we can see that each and every time the 10 to the power more than 10 to the power 9 operations is not supported. Okay. So we have to optimize the time complexity from big of n square to less than this. Okay. So how can I optimize that? So to optimize this solution, so let me take another slide. Okay. Okay. Yes. So to optimize the solution, like we have to check that how this calculation or how this sum is actually coming. So let me take the first example also only. Okay. So we all know that 7 binary representation is 111. Okay. Okay. And we all know that here the constant is given the maximum size, right? Maximum element number is 10 to the 5. And we all know that 10 to the 5 can be represented as 20 bits. So why 20 bits? Why I am saying in so confident that is maximum 20 bits? Because you can do the calculation also. Let me do calculation for you. Like if I do 2 to the power, sorry, my mistake. Sorry. Okay. Yes. 2 to the power 20 and minus 10 to the power 5. 1, 2, 3, 4, 5. So it is coming out 94856. That is a positive number. So we can obviously say that 2 to the power 20 is obviously greater than 10 to the power 5. Okay. So why I am forcing this thing so firmly, because there is a point here. So what is the point? The point is, for each and every element, we can make an array or in storage like of 20 elements. So what the 20 elements do? The 20 elements do, 20 elements, what 20 elements do? 20 elements store as bit. If the bit is 1, then we will store it as 1. If the bit is 0, then we will store it as 0. So what does it mean? So let me draw a shape for you. Like I am drawing a shape. Yes. So here only. Okay. So if we make like 1, 1, 1. Okay. Okay. Let me. Yes. So yes, 1, 1, 1. Okay. And for 3, like we can do 0, 0, 1, 1. And so far, like it will be also like stored in same way. Like Control C, Control V. Yes, that is 0, 1, 1. Okay. And if we store that 5, if we store that 5, so how can we store that? You all can like take as we can all can assume that this is the array of 3 size. Okay. For this array of 3 size, 101, like we have to make Control C, Control V. Yes, yes, 101. Okay, yes. So this is the like 3. Okay, and if you carefully see that for 7, for this 7 has total 3 bits there, because all the remaining bits, all the 17 bits which are in front of this is obviously 0. Okay, so for the second bit, like how many times? So the question is, so what is the main question here? For any number, any number, okay, any number of the array, the jth bit will questions how many times it contributes in the sum. This is the actual question. This is the main question here, okay? How many times it contributes to the sum, and how this contributes, like contributes with which weight, like which weight it will contribute. It will contribute with simply one right shift j. So what does it mean? Like if it is second element, so second element will always contribute either 0 or 4, either 0 or 4. So why 4? Because 1 2 will result as 4. Okay, so that is my point. If this contributes, this this second element will contribute always as 0 or 4. So we have to take that when, in which times this will contribute as 4. Okay, so for that you have to check. We have to check, like if the element exists at ith index. Okay, then from I plus 1 to n minus 1, from I plus 1 to n minus 1, for each and every element, like for each and every element, like how many times this appears to be either 0 or 1 in opposite directions. So what does it mean? Like if the second bit is 1, so you have to calculate that how many times in the same location, in the same bit positions, 0 appears. So if the 1 is here, then in the next numbers, in the same position, how many times 0 appears? 0 appears only 1. So the contribution so the contribution for the second bit of 7 will be what? Contribution of the second bit of 7 will be 1 into 4. That is 4. So why 1? Because as there is 1, so we need 0 only. Because 1s or 1 will always be resultant as 0. So we don't need that. We only need that how many times the opposite bit coming to the next numbers. That is the 1. That is only 1 times it comes as 0. Because for 3 it is 0, but for 5 this is 1. So we don't need 5. We only need 3. So the contribution of the second bit of 7 will be 1 into 4, like how many times it comes, and the contribution weightage, that is 4. Then for the in the same way, we have to calculate that how many times contribution. Let me copy it, so I don't need to write it again. Okay. Okay. Yes. Yes. So contribution of the first bit, like the first bit, first bit, first bit will of 7. How many times? See, the first bit is 1. Okay, so we have to check in the next numbers how many times in the same position 0 comes out. So how many times it comes? For 3, is it coming? No. Is it not? It is not coming, because for the 3 this position is 1. We need 0. But 0, but for 5, yes, it is coming. So it is coming just 1 times. It is 4. So the contribution of the first bit of 7 will be what? 1 into 4? No, because it is coming 1 times, but its weightage is not 1, because the weightage is 1 right shift j. That is 1 cross 1. That is what? 2. Yes. And for the next element, like for the 0th bit, contribution of 0th bit of 7 will be what? Because it is 1, so we need 0 bit. But for 3, is it 0? No. For 5, is it 0? No. So it is not 0. So that's why. So its contribution will be 0. So I am not writing here. Okay. But for 3, we will observe little different case, because here each and every bit is 1. Okay. But for 3, it is little different case, because For the first position, like second bit, okay, second bit it is 0. So we need 1. In the next numbers, how many numbers has 1 in the same position? So this is only 5 which have 1 in the same position. The contribution will be like 1 right shift 2, that is 4 into 1. How many times it comes? That is 1 times, that is 4. So in this way, it is calculated. Okay. So I hope this is clear, like how this is coming actually. Okay. So after that, the how to solve in optimized way, it will be very much clear. Okay. So let me take the another slide. Yes. So let's go to the like how we can implement it. Okay. So we can implement it using suffix sum. So what is suffix sum? So as I have said that for each and every element, we have to take an array of size what? Of size like n, like n for each and every element. So I am taking n plus 1 just for calculation simplicity. And we have to take like up to 20 index. It is sufficient because 2 to the power 20 minus 10 to the power 5 is giving us positive number. But 2 to the power 20 is obviously greater than 10 to the power 5. Okay, and that is suffix. Okay, I have taken this suffix. So actually, why I am taking this suffix? Because if you see that questions, see the like my intuition. Here, main challenge is that for each and every bit of any number, we have to calculate that how many numbers have the same in the same position, opposite bit. This is our main question. So if we get this answer in big of one time, so our task is done. If we get the answer in big of one time, the whole question's answer, so our task is done. Okay. So for giving the for the answer, we have to take an suffix array. Okay. So like let me go to the suffix array. So how can I get that suffix using suffix array? So like we have to just make a simple for loop. Font e equal to I equal to n minus 1 and I the 0 I minus minus. Okay. And here this is the main tricks part. Here comes here. Like we have to calculate like for each and every bits. If it has one, then I will increment that suffix, that position will 1. If this is 0, then we'll simply copy that previous suffix in this position. So what does it mean? Let me do it. Int element equal to array of I. Okay. So for I, int j equal to 20. Okay. J, sorry, let me get right with j 20. J plus plus. Okay. Yes. So what can you do here? Here I will check int num equal to element and one, as I have said, I'm totally doing this way. Okay, no extra task I am doing. What I have explained there. So if num greater than 0, if num greater than 0, I'll just suffix I of j will be suffix I plus 1 j plus 1. Okay. Else what we'll do? I will just copy the next suffix. It is suffix I plus 1 j. Okay. So I have constructed a suffix array. So it will help me to find the answer of the previous questions in big of one time. It will help me to find the questions of the previous like the previous answer find the answer of the previous question in big of one time. So that is our main target here. So after that, we will take the simply like we'll check for simply like formula. Like I am taking this difference because it will be used in the next answer also. So I am doing a pseudocode. So for our understanding, so long answer here 1 to 0. Okay, and we will do a simply little bit different here. As I have discussed, for each and every element, we have to calculate that. We have to calculate what? We have to calculate that if the bit is 1, we have to calculate that how many bits, how many numbers in the next positions have opposite bit in the same position. This is the main questions. I am focusing this question multiple times. Same position. Let me check the mic. Is it okay? Yes. So how many times, how many numbers in the next position have opposite bit in the same position? So if the num greater than 0, it means that position has bit 1. So you have to check how many times it's coming as 0 in the next numbers. So, like how many times? In times, how many times it's coming? And like let me, yes. How many times it's coming? It's coming, it times suffix of I plus 1. Why I plus 1? Because we are currently at ith index. So I don't need ith index because j must be greater than I. So I will look in I plus 1. Suffix I plus 1, j. Okay. So what does it mean? It counts that how many times in the next position, how many numbers in the next position have same bit. Because here num greater than 0, this means the bit is 1. And we are calculating the 1. How many times 1 is coming? But here we need 0. How many times 0 coming? So as this is binary number, either 1 or 0 coming. So like we'll just substitute from total numbers minus total length from this. So what does it mean? Let if there are 5 numbers remaining and 3 has in the same position 1 bit, so we can obviously say the remaining 2 numbers have have 0 bit in that position. That's why it's coming in minus 1 minus I minus suffix I plus 1 j. Okay. So after that we will just, and the contribution is what? Contribution of the bit is what? 1 diced j. So I will just sum it with what? 1 lil 1 j, okay, into times. So that is the sum. That is the sum, okay? Okay, let me do it for you. Yes, yes. Okay, but if the num is get equal to 0, what does it mean? It means the current bit is 0. So we have to, how many times it's coming? Like first we have to copy this. Okay, yeah. So how many times it will be coming? Now I need how many numbers in the next position have 1 bit because current bit is 0. So opposite bit will be what? 1. So suffix I plus 1. That is the how many times it will contribute in the sum. So sum plus 1 plus j into times. Okay. So this is the total like all the this is the actual answer. So the sum here we'll calculate the sum. Here we'll calculate the sum. So after that, we will just have to return the sum. Return like yes, return sum. Okay. So I have to just return the sum. This is our actual answer. So that is the whole intuition behind it. Like I have written the pseudocode also. So that is I have just code it here. I have just code it here. Previously I code it here, and after that I am explaining you. Okay. So let me comment it out. Yes. So that is the code which I have explained that first I have taken the array length, then I have taken in plus 121 because the zero base indexing, and suffix bit I have calculated here. And in the same way as I have explained in the pseudocode, I have written the code. So let me compile it. What is saying? 52. Okay. Okay. Sorry. So there's some bracket issue. Okay. Yes, it is compiled successfully. Let me submit it. Look, this is submitted successfully. So let me analyze the time complexity at last. So what is the time complexity of the optimized solution? So you can easily say with the code structure only. So what I am doing, I am iterating like from n minus 1 to 0, and each and every time we are calculating 0 to 20. It is a constant time. So actually, what the time complexity? Time complexity is very much easy. That is, you can easily say that is time complexity. What will be time complexity? Time complexity will be big of n into 20. Okay, 21 could be as you have as you want to say it will be. So like it will be in asymptotic notation as 21 is a constant, so it is big of n. Okay, this is optimized solution of this optimized solution. And that's why this code successfully compiled and successfully submitted. And this is the like solution, detailed solution of today's questions. I hope it is clear. If any doubt appears, feel free to ask, and I'll be happy to like meet you the next day with the next questions. So till then, take care. Bye bye.